Hello, everyone. We are on 1.1 intervals. Please write down the essential question. How do I represent an interval in multiple ways? So over on the side, I wrote down this information ahead of time, and I'm going to give you a chance right now to write this down to refresh in your memory on these few symbols. When we're dealing with a bracket, that equals include, means you include the endpoints. When we're dealing with parentheses, that means not include. And what I'm referring to is when I start talking about interval notation. That's when the bracket, that's when the parenthesis comes into play. When you're dealing with a number line, a closed circle means you're including that number. An open circle means you are not including the number that the open circle is on. And that is where the number line comes into play. Another thing I wrote down is just a reminder. Whenever we're dealing with the entire number line, negative infinity to infinity, or if we have negative infinity on the left and a number on the right, like right over here that I'm pointing to, negative infinity to 3, or here, negative 2 to infinity. Whenever you're dealing with infinity or negative infinity, there always is a parenthesis on the negative infinity and on the infinity. And that's because infinity and negative infinity are not finite numbers. They're a behavior of something happening out in space. So another thing I want to mention is students always ask, well, I don't know if I put negative infinity on the left or the right. Negative infinity is always on the left. Infinity is always on the right. That's why I'm writing this information down. So what you should do is you should pause the video and then you can take the time to write this information down. I am going to continue. So if you look at this table over here, we're talking about methods of representing intervals. Well, that's our essential question. How do I represent an interval in multiple ways? The other thing I wanted to mention is after we're done with the lesson and we've had time to practice in class, you should be able to answer the essential question. If you cannot, that means you need a little more practice. So let's go through these items right here. If you're talking about words, obviously you're writing words. So let's look at this first row. Numbers less than 3. How that's represented on a number line is an open circle on 3 and the arrow pointing to the left. In inequality notation, the variable is on the left and it's x less than 3. Not less than or equal to, just less than. And that's another thing I didn't write down over here, but I will emphasize right now. If it's an open circle, that's less than. If it was a closed circle, it would be less than or equal to. Writing that in interval notation, because the arrow is pointing to the left forever, negative infinity is on the left and 3 is on the right. Notice there's a parenthesis on both sides because you're not including either endpoint. Numbers greater than or equal to negative 2. Greater than or equal is a closed circle arrow pointing to the right. Again, in inequality notation, the variable's on the left, greater than or equal to. I kind of like to say this. One thing I did not mention, and I'm going to mention right now. I'll get my little pen here out. I call this the nose pointer. It's pointing to the left. This is the nose pointer pointing to the right. That's how I know what kind of inequality to use. Whenever you're writing something in inequality notation and there's only one number involved, your variable is always on the left. Now, numbers between 2 and 4, numbers 1 through 3. We'll kind of do these together. I call this a sandwich situation because the interval that you're talking about is sandwiched in between two numbers. 2 and 4, open circle on 2, open circle on 4, because they're not including those. Here, you're including 1 and 3. That's why there's a closed circle on 1 and there's a closed circle on 3. When you write something in inequality notation and it's a sandwich situation, then I say the x, or the variable, is sandwiched in between the two numbers. So 2, 4, x sandwiched in the middle, and the inequality on this situation, in a sandwich situation, will always be opening to the right. I say the alligator's mouth is open and eating the bigger number. Look at this one, 1 and 3. Again, it's a sandwich situation. The x is in the middle, but this time we have a line underneath each inequality because it's including the endpoints. If I jump over here, and yeah, let's do these first, and then I think I have to go back up here because I think I forgot to talk about this. So right here, we have a 2, 4, and there's parentheses on both sides because we're not including the 2 or the 4. 1, 3, brackets on both sides because we're including the 1 and the 3. In a sandwich situation, there's 2 numbers involved. Up here with the top 2 scenarios, that's not a sandwich situation. The second one, where the arrow's pointing to the right, we're approaching infinity. And I told you back here that infinity is always on the right and always has a parenthesis. But the -2, which is on the left, has a bracket because it's a closed circle, we're including it. If you need to pause the video at any time to catch up, you can. That's the joy of the video. So we've talked about words, number line, inequality, and interval notation. Now we're going to talk about set builder. Set builder is truly just inequality with an extra little piece right there, which refers to the set of all numbers x such that. So the purple here is the set of all numbers x, the line, green line, such that x has the given properties. X is in between 8 and 15. And this is just saying x is a natural number. Now, when we deal with set builder notation, I am not going to make you write this extra piece here, the and x is a natural number, because we're going to assume that you know that. And the symbol means is an element of. So it doesn't hurt to know that, because you're going to see those symbols in your math career. Let's highlight that right there. Is an element. Ooh, is an element of. There we go. All right, so it says video questions. We're not doing the video questions yet. They truly probably shouldn't have been on this page, but that's okay. We're going to go to the next page. And we're going to go and we're going to do example 1. So there are 6 methods of representing a set of numbers. We talked about that. So if I give you words, numbers greater than 3 and less than or equal to 5, what does that look like if we plot that on a number line? So let's do this. Let's do a dash and a dash, a 3 and a 5. This is a sandwich situation because there's 2 numbers. Greater than 3 means an open circle. Less than or equal to 5, we have a closed circle, and I'm connecting them like that. Inequality, it's a sandwich situation, so we know the x is in the middle. We have a 3, we have a 5. I already told you that the alligator's mouth has to open to the right. Open circle on 3, so there's no line underneath. Closed circle on 5, so there's a line underneath. Roster notation, which I think I skipped right over roster notation. I apologize back here. Yes, I did. List or roster notation is just counting. 1, 2, 3, 4, 5, 6, 7. They only include whole numbers, no decimals. We will not be using roster notation very often. So roster notation cannot be written in this example because you can't list the real numbers. I can't list 1, 2, 3, 4, 5 because
we're dealing with numbers greater than 3 and less than or equal to 5. That could be 3.1, 3.2, 3.3, 3.9, 3.98, 4.5, and so forth. So you cannot use roster notation in this example. Set builder, I've already told you in the last page that it is actually inequality with an extra, bear with me a minute. My pen is, okay, let's just go back and back. There we go. All right, sometimes my pen does these crazy things, and there we go. All right, there we go. All x such that, I'm just going to rewrite the inequality. And I said you didn't have to write it with, it's an element of the natural numbers. Interval notation. Well, we have a 3, a comma, a 5, a parenthesis, a bracket. We're not including the 3. We are including the 5. All right. Example 2, we are going to do in class. Example 3. So let's fill in this chart here. Words, numbers less than 3. A number line is going to look like this. So there's our number line. And I need a dash and I need a 3. I need an open circle and I'm going that way. Numbers less than 3. Inequality. There's only one number we're dealing with. It's not a sandwich. So the X has to be on the left. The arrow's pointing that way. So there's my nose pointer pointing that way. There we go. Interval notation. Well, my arrow is going to the left forever. That's negative infinity, 3, parenthesis. You can't do roster notation here. And set builder is just the inequality with this extra little piece, all x such that x is less than 3. Perfect. All right, let's change the color just to make it exciting here. Now, I gave you inequality and we have to do the rest. Well, let's do the number line first. Oops. Okay. 2, it's a closed circle because there's an equal sign underneath. The nose is pointing to the right, so I'm going to the right. So that in words means numbers greater than or equal to, oopsie, negative 2. Forgot the negative, sorry about that. Negative 2. All right, interval notation. I'm going forever to the right. That's infinity. The negative 2 is on the left, bracket, parenthesis, because I'm including the negative 2. Can't do roster notation, and set builder is inequality, just rewritten with this extra little x such that x is greater than or equal to negative 2. Scroll down. All right, we are given set builder. Let's fill in the rest. Well, let's do inequality first because that's just grabbing it and rewriting it without this x such that. We can't do roster. Let's do interval. Actually, no, I don't want to do interval. I want to do the number line first. Here's my 99. Close circle. The nose is pointing to the right. Now I'm going to do interval. I'm going to the right forever. That's infinity. 99 is on the left. That's a bracket. And the words are going to be numbers greater than or equal to 99. 9. Perfect. Example 4, we're going to do in class. Now I'm going to go back because now what you should be doing is pausing the video, answering the video questions in your notes. Have a great day.